Good morning everyone. So in the connection of the virtual work displacement work or virtual work, so now we are going to be trying to solve another problem which is related to the two bars which are connected to in the series way. So here is the problem. The two uniform rods, each of length L. So here is the two uniform bars is there. It means that their cross section is going to be the constant. It is not going to be varying from end A to the end B. The cross section is going to be the constant. That means area is going to be the constant. This is the AB is the one bar and the BC is going to be the another bar. And its length AB is the L and it is going to be have the same length L. And the weight W are connected as shown. So in this case, so that's going to be self weight of these bars is acting in the downward direction. That's we have shown represented in this figure. Using the method of virtual work, determine the theta 1 and the theta 2. There we can see it is not in the vertical, not in the horizontal, but it existed at certain inclination. That's going to be theta 1 AB is making and theta 2 is going to be making with the vertical is the BC link and corresponding to the equilibrium of the bars. So we need to find out here the theta 1 as well as the theta 2 we need to be calculated. Then how we are going to be representing from this part. So there in this case these two are going to be at the same time the force P is going to be acting at the C. There we can see it is acting towards the right side, that is in the horizontal direction. It's very clear that the force P is going to be making only the horizontal direction, the point C. So in this case how we are going to be? For this one I am going to be taking one of the coordinate system at the constant reference. So that I am going to be taking at the A is going to be your reference I have taken in this case. So in this case what will happen, I am going to be giving the vertical displacement, the link AB one time and the vertical displacement to the link BC at the another time. So then when I am going to be making the vertical displacement theta 1, then theta 2 is going to be the constant. I want to make it. And when I am going to be making theta 2, the displacement and theta 1 is going to be 0. So then what is the distance from this part? So can you see this is going to be your reference and this is going to be the self weight is going to be acting. That I am going to be say this is going to be the distance is your y1. So this L is going to be the length of this member. And similarly from this part also I am going to be taking here. So this is the distance. This is going to be y2 I am going to be taking. So how to calculate the y1 as well as the y2 from this one? When I am going to be taking the projections towards this side, there we can see this is going to be making an angle theta and here also it is going to be. So then this vertical distance is going to be your y1. So if I am going to be taking here, I am going to be the point we are going to be say A, B, C, that I am going to be say this is the point D and this is the point E suppose. So this is going to be your D dash suppose. So then in this case what will happen? If I am going to be taking the cos theta, the cos theta 1 is equal to, what is the formula? Cos theta 1 is equal to AD dash by AD I am going to be getting. What is the AD here? That's going to be representing the y1. So that's going to be y1 by AD is equal to L by 2 I am going to be getting. Right? AD is going to be the half of the distance of the bar. So then y1 is equal to L by 2 cos theta 1. And similarly, I am going to be taking the infinitesimal displacement suppose, then what I am getting dy1 is equal to L by 2 sin theta 1 d theta 1 and it is going to be the minus of. Right, that I got it the y1 value as well as the d1 value that I am writing here. The y1 is equal to L by 2 cos theta 1. dy1 is equal to L by 2 minus of sin theta 1 d theta 1 we need to be taking. So once I am going to be calculating the y1 and the infinitesimal displacement of this point which is acting at the W, it is going to be considered. Now I need to calculate the y2 value. So now we need to find out the y2. When I am going to be taking the projections over here, I am going to be getting here is the E dash and similarly I am going to be getting here is the B. It means that it is going to be completely related to your AB link and the remaining half is going to be related to your BC link. So then what I am going to be getting here, So that's going to be y2 is equal to L cos theta 1 plus L cos theta 2. I will get it. Right? When I am going to be taking, this is the vertical component of this part. So theta 1 is going to be the vertical distance from this A to B dash is going to be your L cos theta. And similarly, B to E is going to be L by 2 is there. And this distance, this is going to be L cos theta 1, and this is going to B to E dash is going to be L by 2 cos theta 2. So that same thing I was mentioned here. And similarly, dy2 is equal to what I am going to be getting here, minus L sin theta 1 d theta 1 plus will become minus over here, minus of I am taking L by 2 here, minus is become L by 2 sin theta 2 d theta 2 we are going to be getting. So now we have calculated the y2 as well as the dy2. So y2 is equal to L cos theta 1 plus L by 2 cos theta 2. Similarly, dy by 2 is equal to minus of L sin theta 1 d theta 1 plus L by 2 sin theta 2 d theta 2. We got it. And similarly, we need to be calculate the distance from here to here. This is going to be horizontal component is going to be the x. So that x is equal to, what is the formula we are getting here? That's x is equal to, this distance is going to be L by L cos theta 1, and this distance is going to be L cos theta 2. That is going to be L cos theta 1 plus L cos theta 2. And similarly, the virtual displacements also we are providing to this, the point C. So then dx is equal to minus of L sin theta 1 d theta 1 plus L sin theta 2 d theta 2 we will get it. So once we are going to be getting the virtual displacement, and then we are applying the principle of virtual work. So sorry over here, and the sin theta, when I am going to take the theta 1, this is going to be L sin theta 1, L sin theta 2. So the same parameters I am going to be taking here is the sin theta 1 and here is the sin theta 2. This will going to be your cos theta 1, and similarly this will become cos theta 2. So these two parameters we are going to be varying. Once we are going to be getting, in order to find out the theta 1 and theta 2, give the vertical angular displacement to d theta 1 to the bar AB. So first we are going to be giving the initial displacement, that means virtual displacement to theta 1, and keeping theta 2 be the same. So in this case, theta 1 is going to be the variable and theta 2 we made it the constant. So once if I are going to be making the constant here, d theta 2 is going to be 0 automatically. So now if I am going to be taking the force into virtual displacement, what I am going to be getting here, the P into dx I am going to be getting, plus what is the force here, that's going to be W into d theta 1 I will get it, plus W into, in this case, d theta 2 I will going to be getting. So in this case, d theta 1 we are going to be writing, variable is going to be dy1 I am going to be taking. This is going to be the more appropriate word. dy2 is going to be 0. Then I am going to be substituting in this equation. Then what I am going to be getting, I will find out the value of the p. So then what I am going to be do here, the p into dx is equal to, what is the formula? That's going to be L cos theta 1 d theta 1 plus L into cos theta 2 d theta 2. When d theta is going to be 0, this parameter is going to be 0, only we are going to be getting L cos theta 1 d theta 1 we are going to be getting. And similarly in this case what will happen, the W is equal to be, in this case the W is going to be the self weight, that means of the AB bar. When the AB bar is equal to dy1 is equal to that W into L by 2 minus of, so in this case minus of L by 2 sin theta 1 d theta 1 we will get it. And similarly, Wy2 is equal to what we are going to be, d theta 2 is going to be the cancelled out, only this parameter we will get it. So that's going to be W into minus of L sin theta 1 d theta 1 we will get it, that is equal to 0. So once we got it, this equation, we are going to be simplifying this, and finally we are going to be getting this value is going to be the L will going to be cancelled out, and then the P we had the P cos theta 1 minus 3 by 2, because W and here is also W is there, that when I am going to be making the LCM, that's going to be minus 3 by 2 into W sin theta 1 equal to 0. So once if you are going to be have the P value or the tan theta 1 we are going to be calculating. So from this one, sin theta I am going to be taking and towards the right side. So then tan theta 1 is equal to, when it is going to be there, that's going to be 2p by 3w, I can get it. So this is the equation we have got it. Tan theta 1 is equal to 2p by 3w, we got it. So once we calculated the theta 1, now we need to calculate the theta 2 from that system. Then in this case, the second condition we are applying, give the vertical angular displacement d theta 2 to the bar A, so to the bar B, C, keeping the theta 1 to be the same. So in this case, so theta 1 is going to be the constant, theta 2 is going to be the variable. So it means that d theta 1 is going to be 0 when we are going to be deriving with respect to time or with respect to space. So then I am going to be applying the principle of virtual work. So in this case, what will happen, the p into dx plus w into dy1 plus w into dy2, these are the displacements we are getting. But in this case, theta 1 is going to be 0. When I am going to be taking the x value, can you see the dx is equal to d theta 1 is going to be 0. So once it is going to be 0, I am going to be multiplying here the p into L cos theta 2 d theta 2 plus, in this case, we are going to be w, we are multiplying with the dy1. So in this case, we have only theta 1. D theta 1 is going to be 0, then w into 0 we will get it. Then w is equal to dy2. dy2, can you see here, the dy2 is equal to this parameter. In this case, this is going to be the 0, then only this we are going to be writing. That's going to be minus of L by 2 sin theta 2 d theta 2 is equal to 0. So this is the value we are getting. And finally, what will happen? I am going to be taking the right side and left side. L will going to be cancelled. Theta 2 will going to be cancelled. So that's going to be P cos theta 2 is equal to W by 2 sin theta 2 I am getting. Now finally, I am going to be calculating the tan theta 2 is equal to 2p by W, I get it. So there we can see, when we are going to be having the theta only the displacement, theta 1 is going to be the constant, this tan theta we are going to be getting, that is the 2p by W. If you know the value of the applied force in the horizontal direction, if you know the value of the magnitude, the value of the W, then we can get the calculate the theta 2. And similarly, theta 1 is equal to 2 by 3W, we got it. This way, we are going to be calculating the theta 1 and theta 2 by using the virtual work method. I hope you people are able to understand how to use the principle of virtual work method to find out the unknown parameters like applying the force or internal force or maybe the inclination we are going to be calculating of the specific members. Thank you.